In the following lecture, we're going to learn how to construct redox equations using standard electrode potentials. The table for standard electrode potentials is already provided to us. When we're talking about constructing redox equations, we're going to predict which substance is going to lose electrons and which substance is going to gain electrons, which one is going to get oxidized and which one is going to get reduced. And we will also predict how feasible the reaction is and how likely the reaction is going to be. We've also previously discussed that the higher the E0 potential, electrode potential, the higher would be the tendency for that substance to gain electrons or get reduced. And vice versa, if the electrode potential is lower, you have a lower E0, then there would be a higher tendency to lose electrons and it's going to get oxidized. So this is the main rule. Higher E0, more it's going to gain electrons, lower E0, the substance would lose electrons. Now, to clarify this exact point, that higher potential and lower potential point, I've drawn two electrodes and I've connected them together by a salt bridge and by this voltmeter over here. And this electrode over here, let's say this is the silver ion electrode, where silver ions are gaining electrons and are in equilibrium with silver metal, which is solid. So you have aqueous ions, silver ions in aqueous state in the solution, and this electrode is made out of silver. It's made out of solid silver metal. So there's an equilibrium established on this left-hand electrode where the ions are gaining electrons and the metal is losing electrons, and this equilibrium is established. And on my right-hand side, I have another electrode, and it's called that there's an electrode set up between magnesium ions and magnesium metal. So it's Mg2 plus in aqueous solution, and the metal Mg is over here. The electrode is made up of that, and so what's happening over here is the equilibrium is established. The electrons, Mg2 plus is gaining electrons, whereas Mg is vice versa losing electrons, and an equilibrium is established. And the E0 values of the two cells is, this has an E0 value of 0.80 volts. And that electrode over here has an E0 value of minus 2.38. So the E0 over here is minus 2.38 volts. Now, if you look at the two electrodes, one has a positive potential, it has a higher potential, and the other one has a lower potential. So electrons always flow from the lower or the negative potential to the higher potential. So the movement of electrons is going to be in this direction. Electrons would travel from magnesium electrode to the silver electrode. The negative potential, the electrons travel towards the positive potential. They are attracted by the positive potential. So this is the direction of flow of electrons. So if you relate that with the equation, this electrode is the one that is producing electrons. So if electrons are lost, the equilibrium is going to shift backwards to produce more electrons. So this reaction would start producing electrons, because as electrons travel from this electrode to the other electrode, there's a decrease in the amount of electrons, and the equilibrium is going to try to increase the amount of electrons by favoring the backward reaction. So more electrons would be produced. Vice versa, electrons are being gained by this electrode. So if more electrons come in, then this equilibrium would shift in the forward direction. So it would start gaining electrons. So lower potential, the negative potential over here, produces electrons and gets oxidized, and the higher potential ends up gaining electrons and gets reduced. And I can now construct an overall equation for the reaction. As you can see, silver ions are getting converted to silver. Remember, when two electrodes are connected, the equilibrium is no longer existing, because one side is now favoring the backward reaction, the other one is favoring the forward reaction. So the two electrodes are no longer in equilibrium. They're either gaining electrons or they're losing electrons. So over here, silver ions are getting converted to silver. So if I write an overall equation, it's going to be Ag plus ions getting converted to, in my product side, I'm going to have silver metal. And since there's only one electron being gained, remember, magnesium over here is losing 2 electrons. The amount of electrons lost and the amount of electrons gained, they must be equal. So there should be two silver ions and two silver metals so that they gain two electrons. Vice versa, Mg is getting converted to Mg2 plus, so this reaction would be written in the backward direction. So Mg would be in my reactants and it's getting converted to Mg2 plus. And this would be my overall reaction for the equation. It's going to be silver ions reacting with magnesium metal, producing silver metal in Mg2 plus. And we also previously learned how to figure out how fast this reaction is going. You can measure that by measuring the E0 cell of this reaction, which is the potential difference between the two electrodes. It's the higher potential minus the lower potential. So this side over here had a potential of minus 2.38. This side had a potential of 0.8 volts. The bigger the difference between the two, the more the faster the electrons are going to flow and the faster the reaction is going to be. So it depends on the potential difference between the two electrodes, which is the E0 cell. It's the higher potential minus the lower potential. So our higher potential is 0.8 volts and our lower potential is minus 2.38 volts. And if you calculate the difference comes out to be equal to 3.18 volts, which is very high, which means that this reaction is going to be very, very feasible and very, very likely. So the higher the E0 cell, the faster the reaction. So I've given you a brief overview of how you can predict reactions, which element is going to get oxidized and which element is going to get reduced. The simple rule is that higher E0 values, they have a higher tendency to gain electrons. Lower E0 potential, they have a higher tendency to lose electrons. Now moving on, when we are going to construct equations, I'm not going to draw electrodes. We're going to try and predict reactions like this directly from the E0 potentials using these two statements without actually drawing the electrode.